risks, consequences and benefits, and anticipating the future to help us address and adapt to climate change. The land we use today will affect the climate for generations to come and the challenges we face, from maintaining a balanced Earth to the security of our food and livelihoods. The way we use our land and the way we live will help to secure our future.
Okay, so thank you for your attention, for that film. We were trying to strike an optimistic tone with this. So even if it wasn't Bollywood, we hope there's a Bollywood kind of ending in terms of happy outcomes from this process. But if we could switch now to the presentation. And just to say, the special report on climate change and land that the IPCC produced was just an exceptional degree of interdisciplinary collaboration. It was the joint product of IPCC's 3 working groups: Working Group 1 on physical science, Working Group 2 on impacts, adaptation and vulnerability, and Working Group 3 on mitigation. And just to say, it also involved the Task Force on Inventories, which is the part of IPCC that develops the methods by which governments report their emissions to the Framework Convention on Climate Change. So this was the first time that everybody had actually got together on this. I'm just trying to work out. So this is the front cover, and one of the things I'm going to flag up initially is I'm going to concentrate on where the report came from and why we produced it. Meenal is going to cover the general findings, and Alisher will then home in on the findings on desertification. So just to say, when IPCC at the start of the 6th cycle, the governments decided that they wanted to produce a number of special reports in the cycle. And we actually received from governments and observer organizations 6 different proposals for special reports related to land. And 3 of these were basically on the subject of dry lands and desertification. So one from Algeria, one from Saudi Arabia, and then UNCCD's own proposal for a report on an assessment of interlinkages and integrated strategies on land degradation. So we were very pleased to receive that. But these were not the only proposals we got, because we got a proposal from the European Union on agriculture, forestry and land use generally, and we got proposals from Ireland and the Climate Action Network International on things specifically related to the food system and food security. So the challenge for IPCC was to think about how all of these things would be put together. And the result of all that, when countries negotiate on something like that, they can't put anything down or leave anything out. So we ended up with a report that was intended to be a blend of all these proposals that had come together. So we ended up with an extremely long title for the report, which took some time to actually negotiate. So I will just flag up. The title is problematical in some ways because it mixes a variety of different types of concept. So it covers desertification, land degradation, and food security. And in a sense, they all entail policy objectives that have to be met. Obviously, land degradation neutrality is central to the first 2 of these concepts, but food security is really key to the Sustainable Development Goal number 2 on zero hunger. So that is a policy goal that's in there as well. We had a physical part of it, which is the greenhouse gas fluxes in terrestrial ecosystems, to understand just the physical aspects of the climate-land interaction. And we had a final one on sustainable land management, which is much more about processes, policies, and how we actually achieve our goals. So it was a very difficult task to put all of these elements together. Now, one thing also I should flag, before every report IPCC produces, the scientists get together for a scoping meeting to recommend an outline, but we recognized the amount of parallel and adjacent activity that was going on in other international organizations. So before we actually started the process, as we had 3 web conferences with representatives of different bodies, the IPBES, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, the Food and Agriculture Organization, and of course UNCCD itself. And so we had these 3 2-hour web conferences to talk about the scope of our report in general. And one very clear message we got from all of them was to stick to the climate-land interface. Don't try to do everything to do with land. IPCC is there to look at climate, so focus on the climate-land interaction. And I might say our IPBES colleagues were particularly forceful on that point, given the other reports that they were producing all the time. We needed to have complementary reports, not reports that would overlap. So in terms of the structure of the report we came up with, and the governments did not really change that. They agreed with what the scientists produced as an outline. There's a first chapter on framing and context, where we set things up conceptually. There's a second chapter on land and climate interactions, which is very much the greenhouse gas fluxes, the physical aspects of it. And then we have 3 so-called pillar chapters, where we look at the policy ones that imply a policy objective. So desertification, land degradation, and food security. We then have a chapter 6 that goes into response options, which we deliberately did not classify as mitigation and adaptation, but we can get onto that. And the chapter 7 is more about the risk management and how we enable action in these areas. And as I say, the panel very much agreed with the structure of this report. Now, just before I finish and pass on, just a couple of things on the statistics around this. There were 107 authors from 52 different countries. It was the first ever IPCC report where there were more developing country authors than there were developed country authors. And we did our best on gender, but 40% of the coordinating lead authors were women. And if governments would nominate more women, we would be delighted to take them to improve our gender balance. 7,000 scientific publications, 28,000 comments, all of which had to be responded to individually. And just I would like to flag that it was truly interdisciplinary. There were many other of our authors were associated with IPBES, associated employees of the Food and Agriculture Organization, people from the UNCCD community, so it was genuinely collaborative. And just my very last slide, and this is kind of the media messaging that we developed for immediately after the report being approved. 3 big messages. One about the pressure that land is under from human activities that is being exacerbated by climate change. A strong message that land can be part of the climate change solution, but equally the qualification that land is not a magic bullet. There's lots of other actions needed to take place in energy, transport systems, urban systems, etc. Land can't do it all by itself. But at that point, I will pass on to my colleague Meenal Pathak to take us through some of the general messages. Thanks, Meenal.
Good morning, everyone, and thank you for coming this early in the morning. Delhi doesn't usually start this early. But as Jim said, we are climate change people and we don't usually get invited to land meetings. So thank you for making this happen. I'm glad the report came out and has made this connection very explicitly. So what I'm going to do in the next 10 minutes is run you past the key messages of the report. Jim mentioned the report has 7 chapters, and Alicia will be covering chapters 3 and 4 on desertification and land degradation. And I have picked and chosen the key findings of the report for this session. Well, you probably know this better than I do, but this figure shows the land use, global land use, in different categories. You can see the yellow box, which is the land we use for agriculture, about 12%. The blue, which is the planted and managed forests, which takes 22% of the global ice-free land. The big green boxes are grasslands converted into pasture, which is 37%, and the boxes on the right, the orange boxes, are basically unused land. These are also 3 figures from the summary for policymakers, and I can't see the screen, so I'm going to have to look back. So the first one talks about statistics related to agriculture production, and some surprising findings there that the use of nitrogen fertilizers between 1961 to present has increased almost 800%. The use of irrigation water has increased almost double. Correspondingly, cereal production has increased 250%. But if you look at the second figure, it shows the prevalence of obese and overweight people, which is 2 billion. 860 million people are undernourished or starved. About 150 million children are stunted. And I think 600 million women or teenage girls are iron deficient. So the increase in production has really not improved some of the other well-being indicators as seen on the second graph. And the third one shows the population experiencing desertification. And the report says 500 million people live in areas experiencing desertification, and this has increased significantly in the last 50 years. This is really chapter 2 of the report, how land and climate change interact. So climate change exacerbates existing land degradation processes through rainfall, through temperature, through extreme events, but also the changing frequency and intensity of these events. Land degradation is the driver of climate change through emissions from deforestation, land degradation, the loss of soil carbon, for example, and the reduced uptake of carbon because of changing climatic factors. Emissions from the agriculture, forestry, and land use sector are now a third of the total global emissions. Most of the methane emissions, anthropogenic, comes from land use sector, and this is mainly from paddy and livestock. You already know this probably, but also that a lot of nitrogen fertilizers get released as nitrous oxide emissions, adding to the AFLU emission totals. This one's a risk figure, which we call the burning embers in the IPCC. So the color on the embers shows the intensity of risk. I will go to the first bar. The SSP1 and SSP3 are future socio-economic pathways. So we compare these risks for 2 different pathways. SSP1 is a future socio-economic pathway where you have low population growth, high demand, reduced inequalities, and food produced in sustainable manner. You also have effective land use regulation and high adaptive capacity. You can see in such a scenario, the risks are lower than the SSP3 scenario, which shows higher risk. SSP scenario is a scenario of increased inequalities, food, high consumption and high demand for food, and more unsustainable production systems. So the risks are much lower in socioeconomic pathways where the inequality is lower and food is produced more sustainably. So you can see the risks for desertification in the first 2 bars, the risk for land degradation in the 3rd and the 4th bar, and the food insecurity risks in the 5th and the 6th bar. And I'm also going to point to the horizontal lines. Oh, the pointer doesn't work. So the axis on the left shows the levels of warming. So you can see the risks increasing at increased warming. So it's multiple effects of socio-economic and climate changes. So the purple is the highest risk. So you can see the risks increasing significantly at over 3 degrees. The options for the food sector the report lays out is sustainable production, which is changing agriculture practices. The dietary change, which has received the most interest from media, for this report at least. So dietary change to more plant-based diets, shift away from animal meats, but also food produced in low greenhouse gas intensive systems. And the third one is food loss and waste. Globally, I think about a third of the food produced is wasted, and this leads to about 8 to 10% of the total emissions coming from food loss and waste. I won't go into each of these rows, but this is basically a table of options. So the report assesses several options across the land, agriculture, and ecosystems sector, but also value chain and risk management options, including dietary change and food loss. And the blue, the turquoise, shows the positive impacts, and the orange shows the negative impacts. And Alisha will discuss some of these options in his part of the presentation. But what I wanted to say about this table was that some of these response options are interlinked, and not all of these options compete for land, and some actually have synergies when applied together. For example, dietary change and reducing food loss can actually free up land for other uses, such as bioenergy or more food production. The report lays out that delaying action in the land sector will reduce the mitigation options, and you'll have to implement more land-intensive options for mitigation. Also, to say that acting early will minimize risk, reduce losses, and generate returns on investment. But of course, it has challenges to technology upscaling, especially for bioenergy and BECCS, which also I think Alisha will cover. Well, there are fortunately joined-up solutions, and you probably know this as well, but joined-up solutions need joined-up actors. And so Chapter 7 of the report actually talks about getting people together. And because of the diverse range of people involved in decision-making in the land sector, which includes ranging from small and large farmers to managers to large food production firms and policymakers, so engaging people, the report emphasizes engaging indigenous and local knowledge and empowering women to deliver more sustainable solutions, and also overcoming some of these barriers. Well, this is my last slide, I think. And these are some of the options which Alisha may cover in detail, but it talks about how you need everything from monitoring and measuring. You need better climate information and services to be delivered to the farmers. You need more IT. I think somebody was mentioning the soil health card initiative in India, and some of these initiatives need to be upscaled at different, and so some of these solutions also exist at different scales, from the farm to the city or to the larger regional scale. And my last point is that better access to markets, livelihood diversification, drought preparedness, weather and health insurance, social protection and finance can address multiple challenges. And so finally, the point that Jim also made was that land management can help tackle climate change, but land cannot do it all. So we'll need coordinated action in other sectors, and land is just one of the sectors that will meet it. Also to mention that land as a sink is not indefinite or irreversible, so it cannot act as an indefinite sink for storing carbon. At some point, it will either saturate or it could also be affected by climatic disturbances. So action from all sectors is essential if we want to meet the global mitigation potential of 2 degrees and 1.5 degrees. I will now pass on to my colleague Alisha, who will take you through, I suppose, the elements that are of most interest to you: land degradation and desertification.
Thank you, Minal. Good morning, dear colleagues, ladies and gentlemen. Let me now highlight some of the aspects relevant for desertification and land degradation coming from this report. First of all, as we know, desertification and land degradation are very complex, multifaceted processes. It is very difficult to precisely and comprehensively to quantify their extent and to map them. These studies, which use vegetation productivity changes to measure land degradation, show that currently about 1/4 of global land area is affected by land degradation, was affected by land degradation. So that means something between 1.5 billion to 3.2 billion people reside in those areas. And about 500 million of these people reside in drylands, so they are affected by desertification. As a whole, the estimates show that about 9% of drylands are affected by desertification. Since 1960s, the annual area of drylands affected by drought has increased by slightly more than 1% per year, although there is no evidence for a projected global trend in aridity. Climate change will increase aridity and drought in some regions. So here I would like to mention that, of course, as we know, aridity and drought are two different things. Aridity is a long-term climatic feature, while drought is a short-term event. And then also what is important, droughts do not automatically lead to desertification. They are cyclical, and then often when they are combined with unsustainable land management, human activities, then they could have some desertification outcome results. Another important evidence highlighted in the summary for policymakers of this report is that soil erosion using conventional tillage is currently resulting in soil erosion is currently 100 times higher than the rate at which soil is formed. So that means basically that practically fertile soils are a non-renewable resource in terms of human horizons during which we can plant. So we are basically mining that resource and destroying that valuable resource base. Climate change and land degradation will have very complex interactions. On one hand, land degradation is a driver of climate change, as Minal mentioned, through emissions of greenhouse gases and reduced rates of carbon uptake. On the other side, human-induced global warming has already caused changes in observed drivers of land degradation, such as increased frequency, intensity, and amount of heavy precipitation, and increased heat stress. So continuing global warming would exacerbate desertification and land degradation through increasing floods, drought frequency and severity, intensified cyclones. And so as for drylands, the projections show that there is the area under risk of salinization, soil salinization, can increase. And although carbon fertilization effect is enhancing vegetation productivity in drylands overall, but in many drylands, reduced water availability can play a larger role in modulating the outcomes. So this figure shows the schematic representation of our qualitative assessment, how interactions of climate change and desertification can affect the attainment of sustainable development goals. So what we can see from here, here, these gray lines show the magnitude of impact, and then these different shades of brown show the extent of uncertainty from low to high confidence. So what we can see from this is that there is very high confidence of high magnitude impacts of combined effects of climate change and desertification on poverty, on eradicating poverty, on food security, and also on gender empowerment. And of course, we need to, as it was mentioned by several presentations, including at the beginning by Annette, climate change and land degradation have very strong interactions, and addressing climate change, so achieving climate change adaptation and mitigation without action on land is very difficult and challenging. At the same time, achieving land degradation neutrality without taking into account climate change effects is also very difficult. So that means that actions in these areas need to be coordinated. So not everything is doom and gloom. We already have and know about solutions, response options. So, and there are a lot of things that can be done to address these combined challenges. Many activities for combating desertification and land degradation, such as through implementation of land degradation neutrality, LDN measures, contribute to climate change adaptation and mitigation. as well as to halting biodiversity loss with sustainable development co-benefits. So that means that the pursuit of LDN provides incentives to address land degradation and climate change simultaneously. So let me now give some of the examples of specific response options, technological responses discussed in the report and in the SPM. But before we go, just to provide here, this provides the legend, how to read those figures. As you can see, when you see the effects range from blue to brown, so different shades of blue are positive, so synergies between different actions. And then different shades of brown are trade-offs. And then you can see the intensity of color also signifies if these are large or moderate effects. You will see some letters in the figures like HML, so that means high confidence or medium confidence, low confidence, defining the uncertainty, and then different levels of cost represented by circles, so high cost, low cost. Now to see what if we can turn to this figure. So this is the list of land management options with a large mitigation potential. So in agriculture, we can we have increased food productivity, so we can see that all of these lines on mitigation, impacts on mitigation, adaptation, desertification, land degradation, food security,